Here we have a matrix equation. It's a little more complicated. We're going to start by adding this one to the other side. Now the reason I say this matrix equation is a little more complicated because instead of having a scalar being multiplied, we have a matrix being multiplied. That's what makes it a little bit tougher. So, again, we're not allowed to divide matrices, so instead we're going to multiply by the inverse. The inverse, again, being 1, 8 minus 3, 8 from this diagonal, 3 from that diagonal, and then swapping the 4 and the 2, and changing the signs on the other. So our inverse that we're going to multiply both sides by is 4/5, negative 1/5, negative 3/5, 2/5. Okay. So, making a little more room. So I'm going to multiply both sides by this matrix. Now what will happen on the left side is that it'll end up undoing the 2, 1, 3, 4 that was there. Now, critical thing to keep in mind for this is that matrix multiplication is not commutative. So if I have it on the left, it needs to be on the left on both sides. Well, that's a 13. Hold on. Let's try that one again. So, these two cancel each other out. We're going to be left with x. And you could either multiply this in the calculator. I'm going to multiply it out by hand, though, because I want to remind our viewers how to do that, since we have a test coming up. Alright, so when I do matrix multiplication, I want to run across the first matrix and dive down the first column of the second matrix. So first row, first column, I'm going to get 24/5 plus 11/5. Now I'm going to run across the first row and dive down the second column. I get 52/5 plus 3/5. Then we're going to run across the second row, first column, dive the first column, at negative 18/5 minus 22/5. And one more, run across the second row, dive down the second column, negative 39/5 minus 6/5. So, combine all of those fractions, we get negative 7, 11, positive 7, positive 7, 11, negative 8, negative 9. And that's what x equals.